This is Miss Sebastian, and we're going to look at polynomials and properties of exponents with exponents and division. X to the 7th divided by x to the 5th. When we are dividing exponents, as long as they have the same base, you can rewrite as a subtraction of the exponents. X to the 7th minus 5 would be x squared. The reason this works is because on top you have 7 x's that are multiplied together, and on the bottom you have 5. They simplify out. 2, 3, 4, 5, leaving you with only x squared on top, just like what you got when you subtracted. C to the 17th divided by c to the 11th. Because they have the same base, you can subtract the exponents, and you get c to the 6th. You could also write it out. 6, 8, 9, 10. This gets pretty tedious though. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So then these cancel out. Leaving you with just c to the 6th, just like you had. Three to the 5th divided by 3 to the 8th. Because they use the same base, you can rewrite as a subtraction problem. 5 minus 8 is negative 3. And we can rewrite because as a negative exponent, we can move that to the bottom of a fraction. So 1 goes on top, and we get 3 to the 3rd. Okay, let's show how this one works. 3, 4, 5. Okay, so when you write this out, 3 to the 5th is 3 times 3 times 3 times 3 times 3. 3 to the 8th, same thing. So you're going to simplify by dividing these out. They cancel, leaving you with just 3 to the 3rd on the bottom of that fraction, just like we have in our answer. So anytime you have a negative exponent, you flip it to the bottom of the fraction. If it's on the bottom of a fraction, you can flip it to the top and make it positive. 3 to the 0, anything to the 0 power. 4 million to the 0 power, no matter what it is, will always equal 1. No matter what number you raise to the 0 power, it could be 4 million, it could be negative 3,247. If it's raised to the 0 power, it is always 1. 6 to the 5th divided by 6 squared. We need to know if it's less than, greater than, or equal to 36. So we're going to subtract, because they're using the same base. 5 minus 2 is 3. So 6 to the 3rd, that's 6 times 6 times 6. 6 times 6 is 36, times 6 is 216. So 216 is greater than 36. You could have also rewritten this as 6 squared and said 6 to the 3rd is greater than 6 squared. Either way works. Just do whichever one is easier for you. Negative 8r times 2r plus 3. So we're going to have to distribute, we're going to have to hand out this negative 8r to both the 2r and to the 3. So negative 8 times 2 I'm just going to break it up into pieces. Negative 8 times 2 is negative 16, and r times r is r squared. Then we're going to say negative 8r times 3, and it's a positive 3 because of that plus sign. So negative 8 times 3 is negative 24, and the r just goes around goes along for the ride. So we're just going to write that out again. Now I broke it up into pieces so it was easier to look at, but then we have to put it back together so that it is that polynomial. So negative 16r squared minus 24r. 3a times a squared minus 6a plus 2. So we're going to multiply the 3a times a squared. So 3a times a squared is 3a to the third. Then 3a times negative 6a. 3 times negative 6 is negative 18. A times a is a squared. And then last, 3a times positive 2. 3 times 2 is 6, and the a just hangs around. 3y minus 4 times 4y minus 6. So 3y times 4y, that gives me 12y squared. Then I'm going to multiply the 3y times negative 6. So 3 times negative 6 is negative 18 y. Now I'm going to change colors, and I've got negative 4. Okay, I've got negative 4 here. Negative 4 times 4 would be negative 16, and the y just hangs around. And then negative 4 times negative 6, negative times a negative is a positive 24. Now I've got negative 18 and negative 16 that I can combine like terms because they are both attached to just a y. So negative 18 and negative 16 add together to give me negative 34. And then I bring down the the 12y squared and 24. This is often called the FOIL method. First terms, so the first terms, 3y and 4y, that's what we multiplied first. O is the outer terms, that's 3y and negative 6. I is the inner terms, that'd be negative 4 and 4y. And then the last terms, and that's the last term in each set of parentheses. So negative 4 times negative 6. That's just so you don't forget any of those multiplications.